Hello, this is OCR Further Statistics. We're in Bivariate Data 2, Rank Correlation, and the second video, Hypothesis Testing using Spearman's Rank Correlation Coefficient. This is just a variation on the method for Pearson's Product Moment Correlation Coefficient. The really important thing to remember is that we are testing association and not correlation, so that your null hypothesis will look like this. The hypothesis needs to be in words, with no alternative using row, because we don't define Spearman's rank correlation coefficient on the whole population, only on a sample. The null hypothesis is always the same, but the alternative hypothesis can vary. You might not know what sort of association you are expecting, and do a two-tailed test. Or you might be looking for either positive or negative association. As always, you need to write down your hypothesis before carrying out the test. In real life, that means before collecting the data, although of course in an exam that isn't possible. So let's go back to our cafe owner and see if the association we observe in the sample is significant. We're looking to see if turnover decreases when the maximum temperature outside increases. So our test will be one tail. We're looking for negative association. And we've got a 1% significance level. Pause the video while you write down the null and alternative hypotheses. OK, you should have pretty much exactly these statements. There really isn't much room for variation. Have you remembered to use the word association rather than correlation? That's really important. The test statistic is the coefficient RS, and we calculated this in the last video. It's equal to minus 0.6485. Now we look at the tables. Start by making sure that you're looking at the correct table. You need Spearman, not PMCC, and they're on the same page in the formula book, so you'll need to be vigilant to make sure you are using the correct one. N is the sample size, which here is 10. We're doing a one-tail test at the 1% level. So the critical value is 0.7455. Note that we only have positive values here, but it's all symmetrical, and we're looking for more extreme results. So we'd use minus 0.7455 and look for results which are closer to minus 1. So the critical value is minus 0.7455, which is here. This is the critical region. Values of the test statistic here are significant. Note that the insignificant region contains 0, which is our null hypothesis. Our value is minus 0.6485, which is not significant. So we do not reject the null hypothesis. And we complete our hypothesis test by writing a careful conclusion in context. That's the end of this video on hypothesis testing using Spearman's rank correlation coefficient. In the next video, we'll be comparing tests.